Okay, I know what you're thinking. Ah, man, I'm sorry. I've been slacking with these videos. Um, I just keep getting busy on Saturdays and not getting around to it and forgetting about it and all sorts of stuff. But I have made a bit of progress. Not as much as I would have liked, but I have made some progress. Um, so one thing I've been thinking about is how I'm going to fabricate these tanks that can hold enough pressure. Since I'm using a pressure regulated system to feed my rocket engine, I need to get the pressure in the tanks as high as I can and then maintain it across the flight. And so um, I wasn't really sure what to do. I also wasn't really sure how I could like connect the propellant tanks to another high pressure tank to then like maintain the pressure as the empty. So I was kind of thinking about that. I wasn't really sure. I got my hands on an air compressor, two air compressors actually. My uncle had one and my dad has one apparently. And so, uh, but these air compressors obviously are too big to like fly on the rocket, so I'll have to figure out something else that can work, like in the vehicle on the go. But for testing, these air compressors will do for testing the tanks. That is. But same as yeah. I mean the problem again is like figuring out how to connect like some tank that I fabricate to the air compressor, and also how am I going to fabricate these tanks? I so uh, let's see. I did some more like little calculations here. Just some simple stuff. My goal chamber pressure is to get at least 100 psi, but we'll see how that goes. Um, but so based on uh, the math that I was doing before, I mean, just kind of as a starting point at least, um, I'm gonna try to go with about this much of my propellants, uh, which, so yeah, of course these two will be mixed together because it's a hydrogen peroxide solution. Um, and so with this much in mass for my propellants, oh wait, no, this is the densities. Based on the masses that I had calculated, and based off of these densities, that leaves me with this much volume of my oxidizer and fuel. Um, and so that's how much volume the tanks need to be able to carry. Obviously, there's a lot more for the oxidizer, especially considering how watered down it is. Uh, I don't think I want to risk trying to concentrate hydrogen peroxide because I don't really know what I'm doing, and that could get dangerous. It's already going to be dangerous. But for now, I just work with that, I guess. But uh, so yeah, so about half a liter, a little less for the IPA, the fuel, and just over 4 liters for the oxidizer solution. But yeah, I was thinking maybe I could like 3D print them and then reinforce them somehow. Maybe I could just 3D print them and get away with that. So that's what I did. Oh yeah, so in terms of CAD, we have no CAD. Uh, that's not entirely true, but I did some research on some of the CAD softwares that companies look for. I found a few like the Siemens, like NX, whatever it is, and like SolidWorks and like a few others, Katia or something like that. But let's see. For some of these, you have to pay. Well, for all of them, you have to pay. Some of them you can get by for free as a student, or sometimes it's just like a student discount. But I am technically not enrolled yet since I don't start my classes until the fall, so I don't really have a student discount yet, I don't think. Actually, well, so yeah, I think the Siemens NX one, I think like I didn't need to like what was it? There was just like a student option. It was just kind of like a I guess a simplified version of the software that I could just download, and so I downloaded that, and then I just like couldn't figure out how to open it up. I like I opened the like install or whatever, and I would like click install, and then it just like wouldn't do anything or something. And I like tried opening other files that were downloaded with it, and I don't know, I just couldn't figure it out. So I just deleted it. I'm gonna try to install it again, I guess, and see what happens. But for the time being, I'm just gonna use Blender, I guess, because that's what I know. And so I built a tank in Blender. Oh, look at that. So another piece to the equation is so this was on the air compressor, and I don't really know how this works, or at least I didn't. And then my uncle walked by, and he was like, "Oh, nice! Look at that! Watch this!" Boom. And then I was like, "Oh, how interesting." For a while, I was thinking like the only thing I could think of to like connect something to the air compressor would just be like to like get a ruler and measure like the dimensions of the threads and just try to recreate that like by hand in Blender, which that would be kind of hard, and like who knows how well that would be sealed. But anyways, then he showed me that, and then I realized, oh, this is much easier to 3D model. And so I got a ruler and I measured the dimensions of this guy and made this to try it out. And lo and behold, I think it works. So I did that. Oops. And then I went to Home Depot. I bought some more of these and some other parts as well. I got like a gauge. And then I also found some calipers to give me some much more precise measurements, with which I made this a more precise version, I guess. And so that connects very well, I guess. So yeah. I think it seals. And so I made this, and then I put it on my tank, and then I 3D printed that with my SLA printer. To get this, I had to do it in 2 halves, of course, to get rid of the supports on the inside. And then I used duct tape to hold the 2 halves together. And then I did the pressure test. I was gonna take a video of it to see like what pressure it broke at, but it broke prematurely before I even got my video out. So it really did not handle very much pressure at all. That was kind of disappointing, but I mean, I shouldn't have expected much better, I guess. And so I've been trying to brainstorm ways I could reinforce it. I could just put more duct tape as one idea, or I could like do any number of things. My dad suggested I use epoxy. He's got a whole bunch of epoxies. He's got this weird like sort of clay epoxy that you can like mold around and stuff. He's like, yeah, this stuff is strong. And so I made another one of these. This was just kind of like designed with random proportions, but it turns out that this is actually very similar to the size of tank that I'll need for my IPA, my fuel. And so I adjusted the dimensions just ever so slightly. But I mean, the IPA tank will be about that size. And so I printed another one and then wrapped it in the clay sculpt epoxy, whatever. And that is curing right now. So hopefully in the next video you'll be able to see a test of the pressure test to see how much it can hold. It's just like the 3D print and the epoxy. But one thing I noticed here, so to get the 2 pieces to fit together, they're not just like sitting together like that, just like sitting next to each other with duct tape. They like one slides into the other a little bit, which means that there's a very thin portion there in the middle. right here and right here, well, yeah, the thickness is 1.5 millimeters, which is not very much, obviously. I was thinking I would just like start small and then like build up, um, to see like what the sort of minimum thickness would be to sort of, you know, in the long run get the minimum weight to maximize performance. But you know, we're not really getting much performance out of this anyway. But so yeah, I started with 1.5 millimeters, I think. But what that means that right there, the on each piece, it's only 0.75 millimeters thick. And from the looks of it, you can kind of like, it's kind of hard to see, I guess, but I think that it looks kind of like the crack initiated from this thin point and then like split up and then like broke off right there, or something like that. And so I think the crack was mostly just from the really thin portion. Um, but you know, I mean, I don't think the rest of it could handle much more pressure. I don't know. When I was putting them together, it seemed like, I mean, it wasn't. It might not have been like a perfect fit, and so there might have been, just because of the way they fit together, it might have already had some like sort of weird tension in it. That, um, and then that was just sort of compounded once I added pressure. But So I did that, and so with the version 2, I made it a little bit thicker. I So like right here on version 2, it's instead 2 millimeters, so not much of an increase, but 2 millimeters thick. And then in the overlap section, it only goes down to 1.5 millimeters right there. And then on the outside, it's also 1.5 millimeters, and then it goes back to 2 millimeters right there. So it's like 2 millimeters, 2 millimeters, and then 3 millimeters, and then 2 millimeters, like in total. Uh, and then of course it's all wrapped in like this thick layer of epoxy sculpt stuff. Um, Anyways, so we'll see how that goes, I guess. Uh, that's kind of where I'm at, I think. Okay, and so while brainstorming what I could do about these tanks, and well, yeah, again, I wasn't really sure at first how even to like connect it to everything. I eventually decided to try to look up some like online like forums and things like that, and like rocketry communities that might know a thing. And I found this website, uh, Hunkawa, something related to Hunkawa or something like that, and it had like some like tips for making liquid fueled rockets. And I apparently you can just buy like it was like a seamless aluminum air tank that just like has these like fittings that will fit that, just like ready to go, I think. um and So that might be handy, you know. I was looking online at what some of the sizes would be. For my uh, oxidizer, this like just over 4 liters equates to like 1.3 give or take gallons, and there was one seamless aluminum air tank that was 1.5 gallons. So you know it might be good, might work. But in theory, like if I can get my own 3D, like 3D printed whatever tanks to work, I could just scale it up to do that as well. But also the seamless aluminum tanks might just be easier to work with, and obviously much more robust. As robust as that gets, the aluminum is going to be more robust, I imagine. And so, yeah, I can't remember how much that would cost though. Cost is another thing. Uh, but otherwise, so I I was thinking I might be able to use like a paintball, like pressure canister thing, you know, like compressed CO2 or whatever, to pressurize my tanks. That's just an idea, because those tanks go a lot higher in pressure. Obviously, so there are like three tanks, right? There's the high pressure compressed air or compressed CO2 or whatever tank, and then there's the oxidizer tank and the fuel tank. Um, and the oxidizer and fuel tanks will be at whatever pressure, like hopefully I can get it up to like 150 psi. I don't know if that's realistic or not, but I'll try to get it like at least about that if I can. And then um, the third tank will be at a much higher pressure and will slowly feed into those, because as they empty, the air inside will expand and the pressure will decrease, obviously. And so, in order to maintain the pressure in the propellant tanks and therefore the pressure in the combustion chamber, uh, the tank pressure has to be maintained by that third higher pressure tank. I think I already explained that in the last video, but that's basically what is it called? Pressure regulated feed system or something like that. So I also got to figure out how to regulate pressure, because I can't just have it like, I can't just like open the pipes between the, I don't want it to like all equalize at once, right? It's got to be like slowly throughout the flight. So I also got to look into like valves and things that I can use, that I can control electronically. I might need to just like figure out how to, I might just need to like build my own servos that will like turn knobs and or whatever on like just like manual valves, instead of trying to find like some electric valve. So yeah, I also don't know very much about electronics, so that's something I need to learn, I guess. Gonna have to work with servos and things. Yeah, I was also looking into like laws and regulations, and apparently there are all sorts of laws and regulations around this sort of stuff. So in the end, that might be what what's the word? Just the last nail in the coffin for this project is. I think I might need to get like approval from the FAA to launch this. I mean, like, both the fact that it's no longer, it's like both the fact that it's as powerful as it is, like hopefully, and like how big it is. It's not just like a tiny model rocket, and like being liquid fuel, and especially if I want to like be doing thrust vector control. So that's gonna be hard, but I'll look into what all the rules and stuff around that are. See if I can figure out how to like get approved or whatever. But I don't think there are any problems with me just doing like static fires on a test stand or whatever until that point. So I can keep working. But if I can't like get past the regulations, then this may need to sort of diverge into one or two projects. Just on one end, just make like the liquid fueled rocket engine, and then on the other side, it'd be fun to do like a thrust vector control rocket, regardless, even with like a solid rocket motor or something like that, or like a staged rocket. I don't know. There are a lot of other projects I could do, but yeah. I also need to figure out the injection plate. I think that's going to be hard. I mean, I guess it doesn't need to be that complicated, but I'll have to 3D model it, and again figure out how to connect it well. One thing I don't really know how I'm gonna do is like carefully, precisely measure like flow rate, dictate flow rate from the tanks to the engine. I mean, I guess I have my valves, but like it'll be hard to control that, I imagine, at least precisely and like quickly, because it's gonna need to be like throttling like up and down like carefully as it's like coming in for a landing or whatever. But we'll see. Connecting it from what am I saying? To connect the tanks to the engine, I might just need to like build this thing on both ends, like do that on the tank side and on the engine side, and then like do that right there, and then do that on the other side, and then have them screw together. That's what I was thinking. Or then have like a valve in there somewhere. But I don't know. We'll see what happens. I kind of 3D modeled a combustion chamber and a nozzle. I think I might have mentioned that in the last video, but I haven't fabricated that yet. I guess I don't know how to fabricate it other than to like 3D model it and then just like send it off to somebody that can 3D print it in metal for me, because obviously plastic won't do the trick. And so yeah, I don't know. So I'll hold off on like fabricating that for now. Maybe save that for last. Because I mean, it's also expensive to get it 3D printed in metal, and so I want to figure out like what all the different parameters of the actual system end up being, so I can design around that for the engine. But yeah, I guess that's sort of where I'm at now. Yeah, again, the clay epoxy is curing right now, and so you'll see that soon, I guess. If the clay epoxy isn't enough, I can, just wrap it in more duct tape. I was thinking I also saw this like I have this wire mesh that I could wrap around like in addition to the epoxy. I was looking into what it would take to do like carbon composite sort of wet layup. That might be beyond my skills, but it might be a good skill to have. But I don't know how expensive that would be. I don't know if that would be cheap or expensive, but it's an option, and I think that would be strong. So anyways, see you next week, I guess.